So, quad this is week 63 of the Perl Weekly Challenge. I've already started working on this one, so it's not going to be a full exploration video, but there are just a couple of things I'm going to talk about in relation and alongside showing you my attempts at solving this week's challenges. So yeah, let's get right into it. The first task is about matching text using regular expressions, and the main stuff I've bumped up against while solving this is just a seeming sort of my interpretation of the question, it turns out in the end, and then also just wondering whether regex is different in different languages in like very subtle ways. You'll see one example just now. So I've got some test cases. These three test cases will work with my function because I know they do, and I'll explain a little bit of how and why. But also we'll fix the function so that it should work with all of these in a second, given what I've literally just think I've figured out. Right, so if we split the tests up like this and do last words on each, then I can go through the examples one by one, because each of them kind of shows something interesting about regular expression matching. It shows something different about regular expression matching, and then at the end we will fix my function so that it solves all of these. So the first one, we haven't even got there yet. That's hilarious. Oh yeah, of course. If I do it like this, does it still go through each one? I see. Right. Learn something new every day. Right. So matching E followed by L or A followed by L. This one's pretty fine. So the regex is the left argument and the regex, I don't know how you say it, and the text is the right argument. I'm using quad S, the quad function regular expression E search function from dialog. So we're taking the regular expression alpha, searching. Now you can just get the matches themselves. Alright, so there's an E followed by an L. But dialog's regex regular expression thing also has this little defen widget, which contains all this stuff in the regex match object, which you get back from doing regular expressions. So you can also get the offsets into your text. So this is the index where that starts. So 3 pic omega is the E from the EL. And I can take these offsets and say there were multiple matches, you'd get multiple offsets, and then I can pick the last offset, and then I create this Boolean list of non-white space characters. I can then take all of the indices, the length of my text, and I can partition into the indices of non-white space characters only. Now we'll see me strip a lot of this code away when I fix this function at the end, but yeah, so I take this, I take my lowest offset number, yeah, it's just one number, and we're basically just selecting the group of indices out of these two groups, which one contains our lowest offset. and our lowest offset is 3, so it'll be the first block that we get there, and we can use these indices to index into our text and just get the match back that's in the non-white space bit. So that's fine. Okay, moving on. This time I've had to change what the regular expression looks like slightly, since the option I for case insensitivity just doesn't get input the same way into the dialogue. I don't know, syntax. It's not the same. So there's another thing you can do with quad S, is you could have alpha quad S. Let's just get the match, and then instead of having the question mark I, you could use variant. I think it's IC is 1. So if we just take ch.t, match it there. Yep. So that would also work, as well as without the variant, just using the inbuilt regex option. Then, so in this case, you could just take, oh no, you can't take the last match because we want the exclamation mark as well. So yeah, other than that, this one basically works right through as before. Okay. Last example I got to work. So in yep, so this one says take care that the regular expression only matches individual words. Now I've been using this offset thing. That was how I started doing the approach, and so and I just assumed that what they meant was space in a regular expression doesn't work in Perl or whatever. So I was kind of confused when I was trying things out, and I got as far as, oh damn. Okay, we'll see. Oh yeah. And I got as far as, let's see, neg1 take tests. Oh yeah, so we can skip this into this line. That's here. And I do get a match, right? So spaces obviously do work, but but the point I think that was trying to be made, I've now realized, is spaces in the regular expression shouldn't do anything or shouldn't match, should return undefined, because before you do the processing, you're going to split the text into words somehow. And this is clearly how I'm going to fix my solution so that it works with the last example as well. I was having the issue that, so we have the input, which is just the text string of something, of the numbers from 1 to 1,000,000 separated by spaces. And if I do format iota 10, I get the same thing. So format iota 1e6 would be the input. And the regular expression in this case was 3 and 0 more of any kind of characters, wildcard characters, but just return the 3 if so, except it has to be 3. I can't read regular expressions well. I was kind of fudging my way through this anyway. And then we'll search and we'll just return the match. Takes a little while because it is 1,000,000 numbers, I guess. Or I've killed it. I'll tell you, I don't know. It wasn't very happy doing that, was it? Maybe it was a lot of matches. Maybe just take the first 3. I mean, it's even more problematic when I was trying to approach, the full regular expression includes this caret character, which means the caret says, immediately from the start of the text, then this then this other stuff. And of course it starts not 1, 2, 3, 4 or 1, 2, 3, 4, 5 or whatever. So it's not going to have a 3 at the beginning, which has now made me realize I definitely should be splitting the text up before I do any of the matching. So let's do that. So in fact, this gets rid of the need for all of this offset stuff. All we need, in fact, I've just been calling them that, but I don't actually care. Actually, if we do this, don't even need to set quad AO to 0 anymore. Although it's always good to have a local index origin. Right. Sorry, yes. So the first thing we do is get the words, which is just split on spaces of omega, and then we're going to do our regular expression, alpha quad s, and then just the match itself should work. No, we're going to need some of that nonsense after anyway. Yeah, we are. Okay, never mind. The dream was real, he says. We just need the last of the words. So maybe percent, does that not return the whole thing? Let's find out. And then that's matches, and we just want the last of the matches. So hopefully this works. We can do it on our tests. Okay, not quite. Doesn't work with the first one. That's interesting. Alpha does this. Match each of the words. Oh. Oh yeah, of course. Last matching word. Ooh, no. Test. There we go. Hello and Chet and my undefined, which I think is still fair game because of the matches, although I'm curious now. You just get nothing if there's a space, but since they want the undefined or some kind of special behavior, then I think leave that in. And now, with any luck, even the numbers one will work. So it's from the beginning, 3, 0 more white space characters, some other wildcard stuff, 3 of those in the match. Last word, format O to 1E6. I guess there's something about like doing, okay, I mean there it is, fantastic, but doing regular expression matching on a nested vector of 1,000,000 text vectors is clearly not going to be and it's, using each is clearly not the fastest thing. I wonder like, will that just work? Let's try again. Instead of doing each of the words, we just do it. Still takes a while, but oh, okay. It's long. Whoa. And it contains a lot. Whoa. Yeah, okay, brilliant. So we don't need to use each, and that speeds up things massively. Wow, okay. Yep. Oh, shit. Ah, except this one. We don't have an enclosed result. Can we hack this over with an enclose if simple? Yeah, okay, well, shoot. Well, now we're going to find out, aren't we? Eh, I'll take it. Okay, so that was the last words thing. The last thing I had to do there is literally, yeah, I just changed my solution from one which tries to find the regular expression match in the whole text and then find the whole sort of word that it's a part of. Whereas this new version splits the text into words first using this idiom and then does the regular expression matching on each of those words. And it's kind of slow, but thankfully it's not as slow as the version with each just there. Okay, then we were looking at rotate string. This one went a bit smoother, to be honest. X, Y, X, X. It's sort of defined as a recursion, so I've implemented it as a recursion or an iteration, whatever. So even though my initial right argument is whatever the string is, we begin by priming an accumulator or whatever. This thing alpha, which is going to propagate through. Actually, all it really is a storage for my initial string XYXX and a counter for how many rotations or what number rotation we're up to. So then we perform the rotation as defined. So that's, 1 4 mod 1. Oh no, it's 1 mod 4. Where 4 is the shape of our string, and then we use that to rotate the array, rotate the text by that many positions. Then we check if we're back to our original string, then give me the number that we got to. Otherwise, we want to increment our counter, keep a hold of our original string, and go through the loop again. So one thing I could do, alpha omega, and you can see R each time maybe. Anyway, follow this through. It's a simple recursion thing. It does all of these rotations until we get back to the original string, and then prints out the number we got to. Really nothing fancy there. Nice use of the rotate primitive, which, considering the name of the problem, that's what I assumed it was going to be. Let me just get rid of this quad get, and then I'll put it on the GitHub, and we're good. So yeah, I obviously quite enjoyed the second one because it's fairly straightforward. First one, regular expressions confuse me slightly in general, but with a bit of looking up stuff and trying things out, I can usually get what I want when I need them. And they're quite versatile. So, here are my solutions to last word. It's a little bit fudgy and a little bit ugly, but it does the job. Rotate string is not bad because it's basically just a line for line translation of the algorithm. So that one's pretty sweet. If you're watching, thank you for watching. If you're not, you'll never know. You'll never know.